Okay, before I even start the second derivative, I would like to, this comes in a little bit later, but since we talked about it, I just want to mention something here. So let's see, we have this function. It starts here, it ends here. It does not go on forever. I know you're going to tell me that this is a relative what? Very good. And it's a relative because I can show the open interval. What does it mean, the open interval? The function exists on both sides. And all the heights here are smaller than this one. So this is the maximum height, and all the other ones are smaller. I know that you're going to say that this is a relative min, but it happens for this function the way I presented it, let's say f of x, that this is a relative minimum and also absolute minimum. There is no other value smaller than it. And it's relative because I can show the open interval. All function values are higher than this one. However, here, this is indeed an absolute maximum, but not relative. Why not relative? Because I cannot show you the open interval. The function does not exist on this side. So the absolute maximum can be at an end point. It can be at an end point. But the relative cannot be at an end point because I cannot show the open interval. Here I can show the open interval. The function exists on both sides. That's why this is relative. But not absolute because there is something higher than it. This one happens to be relative, but also absolute because there is nothing lower than it. This one cannot be relative because it's at the end point of the interval. But it can be absolute if it's the highest or the lowest. And this one is nothing. It can never be relative because it's at the end point. It cannot be absolute max because we already found an absolute max. It cannot be an absolute min because there are values smaller than it. So this particular point is nothing. So I'm going to come back to this again. I just want you to understand the difference between absolute and relative. Relative has to be in the middle of a function, not at the endpoints. The function must exist on both sides. Okay, enough of that. So let's talk about the second derivative. So a refresher, f prime of x gives when f is increasing, gives when f is decreasing, and gives max min. Wonderful. Now what about the second derivative of a function? The second derivative of the function gives us three different things as well. What does it say about the function itself? Three different things. Concave, upward, concave, downward, and inflection points or point. What's all this? Okay, so let's discuss that. Let's talk about concavity first. What does concavity mean, upward and downward? So here's a function. See what happens here? We say this is concave upward. We like to say it holds water. And at this point, it changed concavity. It no longer holds water. So this is concave upward, holds water. And at this point, it turns down, which is concave downward. And of course, this is what we call the point of inflection. Or inflection point. So The first derivative tells us increasing, decreasing intervals, max, min. And the second derivative, it tells us whether the function opens upward or opens downward and where it changes concavity. And how do we do this? Exactly how we did it with the first derivative. We will find the second derivative. We will set it equal to 0. We will find the second derivative, of course, and we'll set it equal to undefined. So this is the same theory that we had for max min, but just that we are looking at the second derivative, not the first. So here we set the first derivative equal to 0 or undefined. For the inflection points, we set the second derivative equal to 0 or undefined. After we analyze this, we are able to graph. We were not able to graph without this information. That's why I deferred graphing till section 3.2. Okay, so and there is a little test that I need to discuss, but let's start by looking at page. Remember to stop me if you have any questions. 290. Okay, so let's identify the points of inflection. Let's choose a function, any function you want from these 4. And there are 2 more on the other page, right here. So let's choose one and analyze where the points of inflection are. So 5, 6.
Did we do 6?
Yes, let's do 6. So we only want to identify the points of inflection. But for example, will you tell me if the function has a relative maximum anywhere?
At x equals 0.
And x equals 0. Perfect, because I can show the open interval. Is there a relative, is there an absolute maximum for this function anywhere? Infinity is not an absolute maximum. So this function goes on forever. There is no absolute maximum. It doesn't stop anywhere. Infinity is not an absolute max. Because for some, the infinity may be 5,000, and for others, 10 billion. Infinity is a symbol, not a number. Good. Does this function have a relative minimum? -2 and +2. Does this function? Excellent. That's where they are. And their minimum is 0. Good. The y value is 0. Does this function have an absolute minimum? It has 2. It has 2. Yes. The same 2 points. The absolute minimum is 0, and it is attained exactly where the relative minima are, at -2 and 2. Awesome. Good. So now follow my cursor. Holding water, holding water, holding water, holding water, holding water. Not holding water, not. Yes, holding water, holding water, holding water. So can anyone identify the inflection points, the x values for the inflection points?
Is it -1 and 1?
Exactly. At -1, the function changes concavity. And at +1, it changes concavity again. So the inflection points are -1, 1, and 1, 1. Awesome. I would like, any questions for me here? These inflection points, you will know the calculator. If you want to graph with the graphing calculator, the graphing calculator is useless.
Wait, you said there's no absolute max. Is there a relative max?
Right here.
That's okay. So 3 or 0?
At x equals 0, y equals 3. So one more time. At 0, and how much is it? Is 3. The maximum is not at 3. The maximum is located when x is 0, and the maximum value is 3. So understand the concept, the difference between the two. Where is the max, the relative max? At 0. How much is the maximum? The maximum is 3. Is that better?
I have a question.
Yes?
Why the concavity is not 1.5?
1.5?
Yeah.
Okay.
Negative 1.5 and 1.5.
Okay, because
No.
because negative 1.5 is here.
Oh, never mind. I was reading it wrong.
That's okay. Good. Other questions for me? Okay, so let's analyze any function you would like to look at. We are only going to look. We're going to look at the whole thing, and we can also graph it now. At this point, we can. If you don't choose, then I will.
Can we do 7?
7. It's a quadratic function. So let's choose something a little bit more sophisticated, tiny bit. Because
13?
yes, okay, so let's do 13. Nothing wrong with 7, but it was just a vertex and nothing else. So x to the third minus 27x. Perfect. So please follow my lead on this. So let me write the page number here, 291. Because this table that we are going to use will be the key for graphing moving forward. Okay. So I'm going to get my table going from the very beginning. And here's what the table consists of. Of course, the domain, which is values of x. Of course, h prime, the derivative of the function. Of course, the function values. And we are going to add one more row. And no more rows beyond this. This is it. So can anyone start by giving us, so we are talking about graphing, so now I have to start with a domain. So can anyone give us the domain of this function? Anyone I haven't heard from today? Anyone?
Is it all real numbers?
Yes, it's a polynomial function. Thank you very much. Perfect. It is all real numbers. Now, when I graph, we always know we have to find the x and y intercepts. So the first step here is exhaust h of x. Find everything about h of x. Not the derivative and not the second derivative. I need to determine everything I can possibly fill in here. So that will be those will be the x and y intercepts. So how do I find the x and y intercepts for any function?
Make the equation equal 0 for x and then
Very
plug
good.
0 in
Yes.
for x for y.
Yes, awesome. So here, for the x-intercepts, y equals 0. And we have x cubed minus 27x equals 0. I want to show you because in this class, I'm fine if you use this feature. We shouldn't when it's so easy to graph. I'm sorry, when it's so easy to determine the solutions, we shouldn't do that, but it's okay. So we go to, I need to show from the beginning. So we go to apps, number 9, polynomial root finder. Not all calculators have this. You don't need it specifically, to be honest. Okay, press enter. This is the order. The calculator considers the order, the degree. Can anyone give us the degree of this polynomial? That was the first one we chose, and we said no because it's too easy. What is the degree of this polynomial that we have here?
3.
Yes, degree 3, very good. So enter degree 3, press enter, and the polynomial, the coefficients of the polynomial have to be entered in this particular order. So the coefficient of x cubed is 1. What is the coefficient of x squared?
Zero.
Perfect.
Have x squared.
Yes, perfect. What is the coefficient of x?
-27.
Yes, negative 27. And what is the free term, or the last coefficient, in other words?
0.
0. Perfect. So now I'm going to go press, I don't know, the calculator may just ask you to click on enter. I'm not sure. The software is asking me to click on graph. So we have 3 solutions. So the solutions are x equals 5.2, x equals negative 5.2. Because the degree is 3, we were expecting 3 solutions. Good. So we found the solutions. Immediately I put them in my table where they belong. 0 in the middle with 0, negative 5.2 with 0, and 5.2 with 0. So for the y-intercept, x is 0, but we already determined that. We cannot find 2 points. It will not be a function if we found 2 points of y-intercept. Good. So I have the x and y-intercepts. I also need to determine these limits. If you thought that you could get away from limits, no, you cannot. So I have to find these 2 limits. When x approaches negative infinity, the tendency of h of x, and when x approaches infinity, the tendency of x. So limit as x approaches negative infinity from x cubed minus 27x, and the limit as x approaches infinity from x cubed minus 27x. And then we are done with the function. Only then I can continue with the first derivative and then the second derivative, with everything I can find. So can anyone give us these limits? Which of these 2 terms is the most powerful when it comes to infinity? Because if I have here 2, I have to plug in x equals 2. But if I have infinity or negative infinity, I only need to determine the most powerful term. Which of these 2 is the most powerful term?
Is it x cubed?
Absolutely. This doesn't count. Too small to mention. So now, plug in negative infinity and tell me what you get. Plug in infinity and tell me what you get.
Is it going to be negative and positive?
You mean negative infinity, right?
Yes, and then at the bottom it's going to be positive.
Good. So I copy here negative infinity, and I copy here infinity. I'm done. This is complete. Now I have to move on here. So what do I do with the first derivative? And first of all, let's determine it. So this is step 2. F prime. You know what I mean, h prime. Okay. Can anyone give us h prime? It's right here. The function is here.